Okay, so today we're going to cut with the plasma cutter. This is our plasma cutter. Looks nice and new. So the difference, last week we cut with a torch, which was an actual flame. We heated the metal till it was almost to the melting point and then cut through it with an extra stream of oxygen. So this works a little differently. This is plasma, and plasma is the fourth state of matter. And so how this works is it's electric. We're going to have a ground. Of course, I'm going to show you all. I'm just going to run through it first. We'll ground our material. It creates an arc, which you shouldn't stare right at. So we're going to also have our level 5 welding goggles, just the small ones, level 5 in darkness. And then how this works basically is it creates an arc over the metal, and what it does is it strips it of its electrons, right? So now you have these molecules like bouncing around. This will also be connected to an air source, to the compressor. So as you pull the trigger, it arcs, molecules are bouncing around, electrons stripped. Then you shoot a stream of air through it and it forces it to cut. Okay, so basically that's my non-scientific explanation. Molecules bouncing around, separating, and it shoots a stream of air. The temperature in any plasma cutter could get maybe like 20,000 degrees to 60,000 degrees Fahrenheit, which is like, it's not even like really imaginable. Like I said, like 500 degrees, anything over that's like really hot. But the thing that's really neat about it is that the heat's really localized, so it doesn't, your whole metal is not heating up like with the flame. It's a much neater cut also. And then some benefits are you can make really nice interior cuts if you want to cut an opening or cut organic shapes. You can do that with the torch as well, but it gets a little bit messier, you know, and also you risk more warpage. The hotter, the more you need to cut, your metal is going to warp more. And so because this is, even though it's so much hotter, because it's really just localized, you don't risk the warpage as much. So, okay, so what we're going to do is we're going to hook it up, okay? So, I could have untangled it before. We had plenty of time. Right. Okay. So the plug is here. It's a 220 outlet, right? Okay. I think I mentioned last week too, the plasma cutter is like great to cut with. It's just more expensive than an oxyacetylene setup. So depending on your budget, if you have it, I would go for the plasma cutter. And there's all different sizes to cut different thicknesses of metal. Again, we're still going to work with 1/8 inch thickness or a 10 or 11 gauge of steel. But a couple things to know about the plasma cutter are there are some consumable parts. And from cutting, these wear out. You want to try not to touch your metal too much with the gun. I'll show you. But there are these little consumable parts that will wear out as you're welding. So the more careful you are with the plasma cutter, I'm lying. Usually they come right out. They're all a little different. But the main parts that get worn out are the electrode right here, and the nozzle, and this little plastic cup, okay? The plastic cup will last a while, but like I said, the more careful you are with the plasma cutter, the longer these will last. The electrode and the nozzle are the ones that will run out the first. But we do have replacement parts in the office, so you can ask any of us It'll start to cut really funny, won't cut as straight, and then sometimes the whole tip of the nozzle will be damaged, and you'll be able to see that it's not like a nice little circle anymore. Okay, so the cup goes in first, then the electrode. It's just a little puzzle that's easy to figure out, but you can ask if you don't. Okay, so there's not that much. There's just voltage and an on and off switch. To cut 1/8 inch material, we're going to put it down to 30. We're going to try that. Before I turn it on, we should connect the air. And does everyone know how to connect a hose? There's just a little collar here with some ball bearings in there. You need to pull the collar back and make sure that you hold this in. Don't let go until the collar is all the way secure so that it doesn't pop back off into your face. I hook up the hose completely before I turn on the air, just because it's easier to hook up. Okay. And then just turn the lever in line with the pipe. Now we have air. One on-off switch. We're going to start with the voltage at 30. And everybody should be prepared with their goggles. Okay, so first of all, the gun is just, there's a little safety on the lever, so you can lift up the red button and then pull the trigger. It automatically makes the air come out. Most plasma cutters won't arc. We'll try it in a second, but won't arc unless you're over metal, so it needs to actually react with the metal to arc. So if you're like right outside the metal, it may not do anything, so you have to be angled at the metal a little bit for the arc to happen. And then you heard the air automatically comes out. What I like to do, again, I always talk about doing a dry run when you're cutting, so that you know you're not going to get tangled up, your hose isn't going to get caught on any tables because it could mess up your cut, and you're not tripping over anything. One thing I do differently with the plasma cutter is I sort of drape the hose over my shoulder and create a little slack like this. So now I have a lot more control. I'm not going to get hung up. Some people do weld like this with the gas torch or the welding tips. I don't ever put the gas hose over my shoulder, even though you do have control, just as a safety precaution, because if the hose is cut, then you could potentially have a little flame hanging over your shoulder. So cross that off the list for when you're using oxyacetylene. But with plasma, you're fine, and like I said, it does create more control. So a little slack over the shoulder. I'm not going to put my gloves on yet. Safety, you pull it up, pull the trigger, and then again, this time you can use your pinky, you can use your hand a lot longer without it getting hot or burned, like with the flame. And I like to just position myself to see if I can go the whole way. You want to be pretty close to the metal without touching it, okay? So you may only want to be lifted up like 1/8 of an inch or a little less at most. Once you have your goggles on, it's hard to see how close you are to the metal. So what I do is I start off touching the metal, and then I just use my left hand, or if you're a lefty, the right hand, I start off touching the metal, and then I just lift up a little. It's easier to gauge when you can't see how far away you are from the metal if you start from touching it, okay? So I start kind of touching it, and then I lift up a little, and then I start cutting. I try not to put too much pressure on this arm, because then you're going to end up going very choppy, okay? So just a little bit of pressure, just enough to guide you, but that you can move slowly. So you'll do a dry run and make it, you know, if you can make it all the way across. I use my body to move. So like I said, same thing with cutting with the torch. I separate my legs, kind of a triangle position. If I'm gonna cut a straight line across, set myself up in the middle, and I use my whole body to move across. If you just, so that's why you wanna do a test, so you don't get caught on anything. If you're just gonna use your arms, it's not as steady, and something that's real common is as you're cutting, you end up on an angle like this, and that's bad because your arc gets a lot longer. It could mess up your cut. Your cut could potentially, like, it could stop cutting. So you wanna try and stay mostly perpendicular. You can be on a tiny little angle in the direction you're going, and then go across, okay? Another difference with plasma cutting is if you're cutting and suddenly a spot doesn't cut, you know how we stopped and we heated again until we cut that spot? In this case, if a spot doesn't cut, just continue on, follow your line, because that could make that area messier. So go ahead and continue. If it doesn't cut, don't worry. Just keep going if it continues to cut the rest of the way, and then assess what you have. And if you have to, like, come back and hit a little spot, you do it after, in this case. Okay, so the first thing I'll do is I'll just do a straight line across, and then I'll show you some interior cuts, which this is really nice for interior cuts. Like I said, if you want to cut out circles or anything, it's just, it starts off in the middle better than the flame. Thank you. I'm like, all right, I've already lost the soap, so thank you, Jordan. Okay, it's on. And also, to be perfectly honest, all plasma cutters are different brands. Our voltage here, or amperage, we have 30 up to 60. Do you, by chance, did you see what the max thickness of metal this one cuts? I'm gonna look that up for you guys, we'll find out. So my amperage is a little different on my machine, so we're gonna do a test right now. We're gonna start at 30 and see how it goes, okay? This may be 40, actually, on this one. So I'm going to ground my material. Since I have it raised up on bricks, it won't make a connection if I ground the table. That's not a good spot. That should work. It's a cricket brick. Okay. All right, ready? Well, that's pretty. 30 is just fine. So it's a little neater than then the torch, and it did arc. I just wanted to test it out to see if it would arc outside of the metal. It did arc, but I left it out there for a little bit too long, not touching the metal, and the arc, and we lost the arc. So I wanted to see. So I had to start again over the metal, and then it cut through nicely. 30 is just fine. I'm actually going to lower it to 20 and see how that works. Okay. So this time we'll do.
So anytime
yes.
you work on a new machine, we should do that. We should do a test run just to make sure.
Yeah, I always like to test, just to test it out to see what works. Like I said, my machine is 20 for 1/8 inch material. It also just doesn't go up as high as this one. So I started it off sort of in the middle just to give it a little test. All right. Okay. Okay, so if you want to cut a circle out and you want the circle, obviously you're going to start from outside the circle and then cut into it. I don't like to start like right on the line because then sometimes you end up with like a bigger hole. So if I wanted that circle, I'd just maybe start like 1/2 inch outside or even at the edge and come in. If I wanted if I wanted just the negative space, then I would start within the circle. So I'm going to start within the circle, okay? And but again, not starting right on the line. I'll start a little bit away from the line so I can try and keep my edge as clean as possible. So I'm stopping because see how it's not cutting through and it's just making a mess? Sometimes you can't tell if it's cutting through with your glasses on, but if you notice there's a lot more sparks, and if before the sparks were all on the bottom, it may not be cutting through. So 20 is too low, so we're going to bump it back up.
Can you go back through that same spot?
Yes, actually, can you get me a wire brush, please? You can go back through the same spot, but always wire brush it first. It doesn't cut. It won't cut as well. It's just what I noticed. It won't cut as well. It'll make more of a mess, but it could be like just a little like buildup in soot on it when you cut. And then once you wire brush it, it just kind of brings it back to the bare metal again, and it works. Okay. All right, so we're going to try 25. 30 worked great, but I wanted to bring you through this just in case. Okay, ready? Another important safety thing is, you're working in a space with a lot of people. What I like to do, people are often working on different things, is notify people when you're cutting or welding, especially with the MIG welder because it arcs, and the plasma cutter. I just give a little yell. I'll be like, cutting, so everybody knows. You guys are all watching me and you're prepared for it, but the only problem is sometimes people hear you yell, and so automatically they're like, oh, what? And they look, but it's actually what you want to try and avoid. Yell it anyway. Okay. All right, ready? Cutting. Yep. 30. 30 works.
What if it's too high? What if it makes you notice?
I think it just gets messier. Let's go up to 40 and give that a try. Ready? Okay. Experimentation is good. Okay. On mine, when it's too high, I've noticed you'd think it would cut better, and it just doesn't. Sometimes it doesn't cut, or it's just messier. Okay, ready? Cutting. So that was 40. It was definitely hotter I think in some spots it has a little bit more slag on the bottom. It's still cut okay, but I think it's a little overkill. It doesn't need to be that hot. The other thing is it's a new machine, and I suspect after it gets used a little while, 40 is probably going to be messier. It won't cut. It's cutting like pristine right now, and I think it's because it's new. But if 30 works, that's where we should stay. Okay, so I'm going to cut one more circle out with 30. Okay, ready? Cutting. Well, you guys, I have to say, I think I like 40 a little better. Another thing is, if you notice when I first start, I stayed still for a little while. I wanted to make sure that I actually saw it cut through the metal before I started moving. Because if you start moving too soon before it starts cutting, even if you're at the right amperage, it just may not continue to cut. So I kind of stayed still at first. I waited to see that it cut through the metal, and then I moved. And after doing all those, I actually think that 40 is better. So again, I like to hang, if you have any kind of torch handle in any of the machines you're using, always hang it off the edge because it's soft metal and you don't want to bang up your tips. That's about it. So for 1/8 inch material, we're going to work with 40. Okay? And then a lot of times, and you guys could try it. You could try 30 and 40. I wouldn't go lower than that because it just didn't work. Just so that you can feel the difference. And if you want to bump up a little, bump down a little, after you feel it out, you can. And then it also has to do with speed. So when I had it at 30, I did move a little slower. But then you are going to get a little bit messier cut if you're moving slower. If you're moving too fast, of course, you may not cut through. But 40, I felt like that was a good speed, and I think we'll work with that for a little bit, okay? Any questions? It's not that much to plasma.
So you're grounding it, so you're not supposed to touch the ground? Like, are you going to get shocked?
Well, that's a good question. I've never really come across that. No, you're not going to get shocked. I haven't gotten shocked. You have to ground the material. If I'm working on the table, you can ground because it's completing the circuit still. But since I removed it from the metal, you have to ground the material. So if you do want to keep it further, because sometimes it just gets in the way, like when I was trying to cut the straight line and you're hitting it, so you might want to have it further away. I guess in general, I have it further away just for that purpose, to keep it out of my way. But yes, I haven't ever gotten shocked. Okay. Okay. There's just less to say about this. It's a really nice machine, though.
So I saw that you were like touching the nozzle while you're doing it. It's fine to touch the nozzle as long as the circuit's not.
When I started?
Yeah, just like when you started it.
Well, I tried to not touch it while I was cutting because you can mess it up. It could stick.
But the nozzle doesn't get hot like after you're cutting.
Oh, I was doing this.
Yeah.
You mean that touching?
Yeah.
It just cools off pretty quick. It will get hot if you're cutting for a long time. It's not hot at all right now. So I guess the air blowing through. This nozzle has little grooves in it, which is kind of nice. So it's a little different than mine. I think the air is like shooting out the sides and cooling it. It probably already also keeps the nozzle and the electrode a little safer with this type of tip on top. Keeping it cool so if it does touch, it doesn't burn the insides. There's a couple more pieces on this torch tip than mine, and I think it protects it a little bit better. it cools fast. But if I was cutting for a long time, it'd probably still be warm. It's not even warm right now, so that's a plus.
And so with the oxyacetylene, you said do a slight angle, but with this one you don't have to.
You don't really have to do a slight angle. I think I do a little bit out of habit, but you don't really want to create a longer arc because that messes up your cut. And I think these grooves in the top, and again, that's just my guess after cutting with it, helps it so that you can stay a little bit more perpendicular because it has these little grooves for the air to pass through and to breathe a little bit. Do you guys want to try? Okay. And you can cut out, well, I'm always like, cut out your initials so you have something to take home. But whatever you guys want to cut out, you can cut out.